So welcome back. We still have some highlights in this conference, 2 keynotes and 1 slot with interesting paper presentations. But now I'm very happy to introduce Franzis Preckel here as our keynote speaker. Franzis is the gifted research person in Germany. I'm sure she is gifted herself too, but she is very well known for her research. She is a psychologist. She had an early history of working in intelligence, but then also educational researchers like to learn more about gifted education. So she got different offers. I think she could have gotten an offer from almost every German university, but she decided to stay at the University of Trier, where she holds her professorship on gifted education since 2006. Trier is a very little city. It's famous for the Roman history, but now it's also famous for gifted education research. Franzis has published about basic ideas about intelligence. We heard nice talks about the differentiation effects, but she also has a lot of recommendations on how to scientifically based make decisions about gifted education. Thank you for coming.
Yeah. So, thank you very much, Elspeth. So, thank you very much. I'm happy to be here. I'm a little excited to be here too, because during the last years, I spent a lot of time at conferences in educational psychology and not that much time at differential psychology conferences, although I somehow identify as a differential psychologist and started my research in intelligence and assessment of intelligence. Actually, it was a rule-based construction of a figural matrices test. So I'm happy to be back, and I hope I have something interesting for you. The heading of my research and the research of my team is talent development. So that's the overarching question. How does potential eventually evolves into achievement, and what comprises potential? Does it vary by domain? Does it vary by developmental level? Are there interactions with age? What factors can be used to foster, to enhance this process? So these are the big questions that are guiding the research in my group, and some of it you've heard already. And naturally, if you're interested in talent development, you have to study intelligence and you have to study schooling. So, and I try to present some of our research and discuss it under a developmental perspective, including talent development. So this is the overview. I'm going to start with some findings on the development of intelligence in the school years, and then I'm discussing the question and also presenting some findings on the impact, the causal impact of schooling on the development of intelligence. We already had a talk on this topic using policy change, G8, G9, and its effect on the development of intelligence. So it's quite similar. And then I'm having a closer look at the situation of intelligent, highly intelligent students in school. Here in this conference, we sometimes had some comments, oh, is schooling really a good idea for talent development? So I'm going to discuss this with some of our findings and focus on teachers' lay conceptions about highly intelligent students and also their competencies to identify these students. And then there's a short excursus on also parents' diagnostic competencies to identify intelligence in their children. We had a nice talk this morning on the impact of family and the connectedness between family, parent issues or characteristics and child characteristics. But even if there is a connection, that does not necessarily mean that parents are aware of the diagnostic, of the intelligence or the potential of their children. So I'm going to focus this question and then discuss this under this developmental perspective. For those of you who have attended ISIR last year, you might be already familiar with these findings. Moritz Breit presented this meta-analysis of longitudinal studies last year. It's a meta-analysis comprising nearly 1,300 manifest test-retest correlations of about 90,000 participants, and it tackles the question about the rank order stability of intelligence test results. And this is what we found for age 20 and a 5-year interval. So there was a pretty high stability of 0.76 and disattenuated. It was 0.86. And you can see that there is an exponential function with a steep decrease in the early years. And this is the age-moderated curve for non-corrected coefficients, and this is adjusted for reliability. And I'd like to focus your attention on the first effect sizes that we have here, because there's a lot of things going on, and you can see that stability isn't very high in the early years, and then there's a steep increase, but still up to the age of around 12, stabilities aren't really reaching reliability levels that we need to use test results to inform decisions. And this can't be traced back to low reliability in testing children, because you see that this age-moderated curve isn't affected that much by reliability differences. So there's a lot of growth going on during these early years. And this growth, the findings that you see here are for the complete data set, comprising a lot of different factors, and we organize them under the CHC model. And here you see the the age-moderated curves for the overall data set, but here's G. Here are more knowledge-based abilities, more processing-based abilities. And for those abilities where we had enough effect sizes, you see that this exponential function really describes the change in stabilities over time, and the steep increase in the early years can be found everywhere. And at a first glance, it seems that those knowledge-based abilities are also G, were more stable, but after correcting for reliability, it wasn't the case. So the stability was quite comparable over all different abilities that we used here from the CHC framework. So here's another way to depict that. Again, for the overall data set, not distinguished by abilities, you can see if you accept 0.8 test-retest reliability as a benchmark for using test results to inform educational decisions, you see that on average you don't reach this reliability before an age of around 10 or 12. These lines here refer to different starting age groups. So these were children tested at age 2 first time, and then you see the decrease in stabilities depending on the age of retest, so the length of the retest interval. And there's really a steep decrease, and that resembles an interaction. So the younger the children are, the more longer test-retest interval matters and really affects the half-life of test results. And this needs to be taken into account when working with test results, and in giftedness research we usually do this. So this is very important for my field. Okay. So to wrap this up, we find these low rank order stabilities in cognitive abilities that are not only found for specific abilities, but also for G. And there was no differences between knowledge or processing-based abilities. That indicates that there's a lot of development going on and that there's a high heterogeneity in these developmental trajectories. And we know from lots of research that this heterogeneity can be explained by many processes, maturation, biological factors, developmental issues, but also by school. And this is something I want to focus on the next part of my talk. Again, we have a lot of research finding showing already that not only the quantity, but also the quality of schooling affects the development of intelligence or cognitive development in general. And it's very hard to do research in this field because age is confounded with maturation, with the amount of schooling. So you really need smart designs to unconfound age and schooling effects. And there are different solutions to do this. For example, Stelze, they controlled for age by just measuring children at or around the 10th birthday. So they were all 10 years old, and then they used their amount of schooling to predict intelligence differences, and they found that around 6 to 9 IQ points could be explained by schooling effects. And then Kahan and Cohen, they used another design. It's a discontinuity regression design. They used the age-based cutoff for school entry and then used this to experimentally manipulate schooling and found that this effect amounted to 2 to 8 points. Brinch and Galloway, they used a policy change in Norway where there was 2 years more of schooling in adolescents, found an increase of 4 points, and here's another regression study. So I picked those studies because they are ordered by age, and it looks as if with increasing age, schooling effects decrease. However, and we've already heard this in the other talk, there is this meta-analysis, this fabulous evidence base from Ritchie and Tucker-Drop, and they found no age moderation effect. Rather, they found that the study design moderated these findings, and the largest schooling effects were found in these regression discontinuity designs. So I had a closer look at the original study base, the original studies that went into this meta-analysis, and there were very few with children in their first years of schooling. So usually they started around grade 3 or 4 or even later. So I wasn't really convinced that the schooling effect is maybe even bigger in the first years or not. So I had no really convincing answer to this question. And we were lucky to have a data set where we could tackle this question by using a discontinuity design. So in this study, we're still analyzing the data, so I have preliminary results. We were interested in the question on the effect in younger children, and the data stem from 2,000 students in grade 1 to 4. It's a standardization sample of a group intelligence test, the THINK, that was developed in my team with Tanja Bautzon together, and it assesses mainly fluid intelligence in children. And the design has a special advantage that in Germany, if you investigate elementary school students, you don't have selection effects, because we have a strict policy that you are assigned to a school in your neighborhood. I know that neighborhoods differ, but still you are assigned to a school in your neighborhood and you have to go there. It's very hard to pick another school. You can go to private schools, but there aren't that many. So we have a pretty rigid catchment area where you have to go to. So this somehow controls for these selection biases. And we assessed students, it's a cross-sectional data collection, but we distributed our points of data collection over the quarters of the different of the school year. So we assessed students in the first, second, third, or fourth quarter. And then we had 4 versions by grade, but they had considerable item overlap, so we could do a chain link equating using a 1PLIRT model, which solved the problem of varying norm groups. So they were on the same scale, on the same different scales, and could be compared. And then we used this hierarchical regression design. We used the date of birth cutoff for school entry. So we have a specific, they vary a little bit in the federal states and Germany, but you have a specific date of birth. And students who are born before this date, they go to school 1 year later, and students who are born after this day, they go to school the same school year. So we have a natural experimental design that nearly same-aged students differ in the amount of schooling by 1 year, depending on the date of birth cutoff. And so we only took the students with normative enrollment into account and controlled for those with early or late admission. These were about 10%. And these are the findings graphically depicted, showing the relationship between intelligence, grade level, age, the interaction of both, and time point of measurement, the 4 quarters. So we predicted intelligence by grade level, age, the interaction, and time point of measurement. And what you see here, these lines refer to different classes in schools, And this black line is a fixed effect of age within a specific grade on intelligence. So this resembles the age effect. The slope shows that this is a small increase over time here in each grade, which seems to flatten a little bit. And then you have those discontinuities, and that's a schooling effect, because when you compare students here in second grade with those in first grade who don't differ very much in age, it's just a few days or a few weeks, but these students, they have 1 year more of schooling. So for assessing the schooling effect, you only have a look at this, they say in this methodology literature, donut hole. So you have a look only at this pieces here, the between grade comparisons, and these continuities, they give you an estimating for the schooling effect. And we found that 1 year, additional year of schooling went along with half of a standard deviation increase in intelligence. And in this study, it's always 1 additional year. It's not 2 or 3 additional years. It's always those students that were behind the cutoff went to schools compared to those before the cutoff. So it's always 1 year of schooling more. And at the same time, the age effect was 1/4 of a standard deviation. And as you could see here, it also flattened out. So we had this interaction. And we translated this to numbers. So here again, you see the sample size within the 4 grades, the theta score on the IoT scale translated into differences between grade 1 and 2, 2 and 3, 3 and 4. And in SD, these were the effects that that showed the overall increase in intelligence by 1 year, and the share that went back to these discontinuity effects is shown here. So it translated into IQ points. This is about 7 IQ points, and this is about 5 IQ points. And it looks as if the increase, the schooling effect, decreased over time, but you all have noticed by now that the increase wasn't stable, so it was larger at the beginning and then became smaller. So taken relatively, the schooling effect actually stayed stable or even increased. So it seemed to accumulate over time. And it explained in between grade 3 and 4 about 80% of the increase in intelligence. So this is pretty much. Okay, so this is some evidence from our research that schooling is beneficial for students' cognitive development from grade 1 on, and that this effect seems to be stable or even increasing over time. There's more research needed here to really answer this question. Now I would like to have a look at another aspect of school, namely teachers. Because in Germany, or let me talk about their role first. So teachers are important, we all know. They provide instruction, select the learning material, set the goals, give the feedback. They act as role model, and especially in elementary school, but also in adolescence, they really are important for teacher-student relationships, which again impact student learning. But in Germany, teachers usually, neither in their training nor their education or later on, learn a lot about intelligence, about individual differences in cognitive ability or giftedness. So most of the teachers have no professional knowledge about these factors and their role for learning and talent development. So we were interested in what do they think, missing this education. What are their lay conceptions, and are they somehow consequential for students' development? And do they recognize intelligent student at all? They are trained to evaluate and to assess academic achievement. And here they are doing a pretty good job, but they are not trained in identifying cognitive ability or learning capacity or potential. They were never trained. So how good are they doing this? So first of all, what do they think about these students? We've heard, I think it was on Monday, we've heard a talk about health issues in gifted students when they were given feedback that their achievement was wrong, so they were stressed and so on. And this nicely resembles with a very prominent stereotype that's out there about gifted students, that their high intelligence comes as a prize, namely socio-emotional issues. That they are somehow more intelligent, but also have more allergies, are anxious, introverted, and somehow deficient. And actually, I'm reading a lot of these papers, and when I find a paper having a representative sample, not being pre-selected by being in a counseling center, a specific school or society, I never find these associations. So there's pretty much evidence that this stereotype connecting high intelligence with socio-emotional issues is wrong. There are highly intelligent students having those issues, but there are average ability students having these issues too. So this is nothing that is really connected causally. So this is interesting. If this stereotype, because it's very prominent, Big Bang Theory and all these movies, they really transport this, if this is in the head of teachers. And we did an implicit association test because we didn't want to ask teachers. It's too obvious. They would socially control their answering. So implicit associations are based on reaction times. You can manipulate them, but it's harder. So what we did is, here were pictures of children. And first of all, these were teachers in training. They learned who of those children is gifted or of average ability. They either saw girls or boys, so it's a between subject design to control for the impact of gender. And those pictures were randomly chosen, and they were neutral against these variables that we were assessing. We piloted this. So first of all, they learned that these 3 girls are gifted and that these 3 girls are of average ability. They were sitting at a computer, pressing keys and sorting the pictures in either gifted or average ability. And as soon as they were able to do this without any mistake, the implicit association tests began, and we assessed the implicit association between the concept of intellectually giftedness and high intelligence on the one side. Seems to be trivial, but has never been shown experimentally that there is this association, and socio-emotional issues on the other side. We did this by presenting words, and we assigned these words either to the same keys as the gifted pictures or the average ability pictures. So there were different rounds of pressing keys, and by estimating the reaction time differences between the condition where the words were on the same key, like the gifted pictures, versus the words on the same key, like the average ability pictures, you could assess as implicit association. And we did this for socio-emotional issues too. And then we were interested in, okay, if there is this stereotype, does this go along with a specific evaluation? So do teachers, for example, like students better or less when having this stereotype? And we assessed this by an effective priming task. So again, teachers saw the picture and had to sort words afterwards. And these words were really very positive or very negative. And their task was to evaluate if it's positive or negative word by pressing the respective key. And the idea is, if there is a positive evaluation implicitly connected to a gifted child, teachers would be faster sorting positive adjectives because it matches than sorting negative adjectives. So again, reaction time differences. And this is what we found. We found that intelligence for girls and boys is positively associated with giftedness. Okay, not a big surprise. And we also found that socio-emotional issues are not associated to giftedness in girls. Remember, it's always a gifted girl compared with an average ability girl. So it's gender is held constant. And here but socio-emotional issues were significantly associated with gifted boys. So gifted boys, as compared to average ability boys, were associated with having these socio-emotional difficulties. And then we assessed the evaluations, first in a baseline before doing this IIT, and they were neutral. But after doing the IIT, we had a salience of either intelligence or socio-emotional issues, And this is interesting, I think. After doing this implicit association test on intelligence, we asked for the evaluations, and I was expecting that gifted students were evaluated more positively than average ability students, because I thought being clever, smart, witty, intelligence is something that teachers would value, but it's not. It's neutral. No association with evaluations. So intelligence is not something that is positively evaluated in our sample with the school teachers. However, after the IAT with the socio-emotional issues, we found a negative evaluation of gifted boys because it was associated with giftedness not in girls. So there is evidence for an implicit stereotype against gifted boys. We also assessed this in a different way, more explicitly. We presented vignettes, just a short text. The cover story was its first impression formation. So Thomas or Karen, sometimes we also assess the impact of gender. As a student at the school where you've been teaching for 1 year, Thomas is a gifted student, an average ability student. That was manipulated experimentally. In some of those studies, we also included has many friends or left out this further information. It had no effect. And then there's this further sentence, today Thomas's teacher is sick and therefore you teach, and students can do whatever they want. And then teachers were presented a personality rating scale and were asked to rate the student described in this vignette. And the first very surprising finding is that we had nobody not being able to do this. I was expecting the reaction, I can't rate the personality of the students, I have no information about him or her. But this was not the case. And we conducted this study in Israel, in Australia, in Luxembourg, in Belgium, in Germany, in the States, and findings were comparable. What we found is that gifted students compared to average ability students are perceived as more introverted, less agreeable, less emotionally stable. These were mean effect sizes, and they are not supported by empirical findings, that they are more open and higher in intellect. So this is actually consistent with the evidence, and it was a large effect. Findings were heterogeneous for conscientiousness. We also found that they were rated at less socially competent, more anxious and more demanding, and being difficult for the teacher to teach. And this was not related to teacher covariates like age, experience in teaching gifted students, gender, or also student gender. So pretty consistent findings. Okay, so there seems to be a situation in which this lack of teaching teachers about giftedness and intelligence, it seems to be that these lay conceptions are very robust, prevalent in school in different cultures. And the next question we wanted to know is, do they identify those students? So when they have this conception, do they use it for intelligent students or is it random? And there's a meta-analysis by Niels Machts and colleagues, and they found that teachers aren't as bad as their reputation in assessing students' intelligence. So the average correlation is 0.43, which is not that bad. So the judgment of the cognitive ability and the actual cognitive ability. However, the judgment of cognitive ability by teachers is way higher with students' academic achievement. So here you have a correlation of 0.43, and the correlation with students' achievement is 0.61. So this points to an academic achievement bias, that teachers don't differentiate between students' achievements and the grades they assign to this and their cognitive abilities. And there were further biases, like higher judgments for boys. We had a fabulous talk on Sunday about gender differences not being always gender differences. But here in this meta-analysis, that was a pretty consistent finding that when controlling for students' intelligence, teachers really assigned higher intelligence to boys, to students with higher SES, students with higher academic self-perceptions, and it varied widely. So we conducted a study in which we tried to replicate these findings and add to this by investigating the role of the classroom. So classrooms differ considerably in average intelligence levels. And we were interested in the question if this average intelligence level of a classroom affects teacher ratings of students' intelligence by a contrast or reference group effects. You know this for academic self-perceptions, and this has not been investigated that much for other estimates. And we asked teachers to rate each student in their class on the 6-item scale. Here are some sample items, which had a pretty good reliability and was normally distributed. This is important for the findings. Okay, then by using hierarchical regression and multi-level regressions, we explained the teacher judgments by actual IQ. And you see that 44% of the variability in teacher judgment could be explained by real test differences, which is pretty good, actually. But then we took further predictors into the model, and the relation decreased considerably. And here you see that the lion's share went to academic grades. So teacher judgments of students' cognitive abilities are very closely aligned to their grades. And grades and intelligence, they don't correlate perfectly. We all know there's a pretty strong correlation, but there's a lot of room for variability and other factors explaining this. So here again, another indicator for the academic achievement bias. We found that boys' intelligence was judged higher. We found that being acquainted with a student biased the judgment. Being more acquainted went along with higher judgments, and also speaking another language as German was detrimental. Having high SES parents was beneficial. Having a high academic self-concept was beneficial. And also the reference group made a difference. So it depended on the classroom you were in. And you can see this here in this picture. This is the class average cognitive ability from below average to high average. And these are the residuals from predicting teacher judgments by using the IQ. So this is the bias. And it's systematically related to average ability level in school. So students in classes with a below average cognitive ability were overjudged, overestimated. Students in higher ability classrooms were underestimated, and the most accurate judgments were found in average ability classrooms. So this is teachers really avoid extreme ratings. There is this tendency towards average judgments, and this comes at a cost for highly intelligent students in higher ability classrooms, and you have the same findings on an individual level. So there are other studies showing that students of higher ability are systematically underestimated by their teachers, while lower ability students are overestimated. And parents, do they do a better job? So we had the same parents in the same sample, same scale, and the correlations with the children's IQ was lower. Again, we had this academic achievement bias, a very high correlation with children's grades. Parent with a higher education, here's a proxy for it, gave higher ratings, but it was not related to children's gender, parents' gender, or birth order of the children. And we did another regression analysis, and you see here that we could explain 22% in parent ratings by IQ test results. And we were interested in the question if also parents underestimate more intelligent children. So we included a quadratic relation as a predictor, and this was significant. And you can see it here. So the higher the intelligence of a child, the lower the parent ratings. This, in part, was due to a ceiling effect in the parent rating scales because parents in general tend to overestimate their children. And this leads to this ceiling effect in the scale. However, that's not the only explanation, in my opinion. We also found that when including academic achievement, that is the grades of the students, there was no significant relation between children's cognitive ability as assessed by a test and parent estimates, but it was all explained by grade differences. But the quadratic relationship remained. So we had a closer look at those grades, what's going on with these grades. And together with Zevolod-Scherer, we found, and this was really striking, it's a very new finding, I think it's really striking. So here you have the cognitive ability level as assessed by the same IQ test, and here you have the math grades of the students and the language grades of the students in grade 3 and 4. Here is the relationship for boys in yellow and in blue for girls. And it's both quadratic. So with higher intelligence levels, the association with grades vanishes, decreases. And it's not a ceiling effect. As you can see here, this really resembles the data. And for girls, you can find it 1 standard deviation above the mean already. And it turns negative, and not in math. I mean, math could be alternatively explained by stereotypes or whatever, also in verbal grades. And we try to replicate this, because it would show that in school, higher intelligent students can't profit in terms of getting better grades to the same amount as lower intelligent students. And that would be, worrisome. Okay. What are the consequences of these biases? So there's underestimation, there's overestimation. Does it matter at all? And there are studies showing that under and overestimation are predictive longitudinally of the development of student self-concept, interest, attitudes, values, and they are cross-sectionally related to aspirations. We had aspirations this morning when Wendy was presenting enjoyment, expectancies of success, and also test anxiety. And usually in all of these studies, overestimation was positively related to student development and underestimation was negatively related to this development. So we had a closer look at this too and tried to replicate this, and we used the same sample, used the residuals from the prediction of teacher judgments by intelligence, and using the residuals we formed groups. So residuals smaller than half a standard deviation, those were the students that were overestimated, accurately judged were within half a standard deviation, and underestimated above a quarter of a standard deviation of the residuals. And you see that this is systematically associated with students' intelligence. So the higher, the more underestimation. And we were interested in socio-emotional consequences or correlates. We only had cross-sectional data. Correlates of this under and overestimation. And to rule out that these intelligence differences alternatively explain our associations, we use propensity score matching. We use the tool that Julian Urban developed together with others in my team, where you could use matching with multiple groups, not only 2 groups, but we have an R package available where you can match 4 or more groups using propensity score matching, which is very neat. So we used this, and here are, we couldn't assign all of these students, so we had around 100 in each group. There were still intelligence differences, but considerably lower, and we also matched these students by gender, their language, parental education, teacher acquaintance with the students, and the classroom they attended. So they are similar, intelligent, same background, same gender, same teachers. And here are the standardized mean differences before and after matching, and we were pretty successful in getting rid of these a priori differences. And here are the findings for their socio-emotional experiences in school. This is the overestimated group, accurately judged group, and underestimated group. And you see that the overestimated had the most beneficial profile, high academic self-concept, joy of learning, willingness to make an effort, or also feeling accepted by the teacher. So also tackles socio-emotional relations. Accurately judged were average, and underestimated were below average. And this could be also significantly tested by linear discriminant function analysis. So we use those profiles to predict group membership, the other way around. And we could classify 42% of the students correctly, which is pretty good, actually. And especially academic self-concept, willingness to make an effort, and also feeling of being accepted were the most pronounced differences between those groups. And they are of equal intelligence, same teachers, same background, same gender. So it's cross-sectional, but I think this is, very, very strong, suggesting that there is a relationship that is systematic. Okay, so schooling is beneficial for students' cognitive development from grade 1 on. Seems to accumulate, but we need more evidence on this. Teacher conceptions, on the other hand, they might be biased. Teachers and parents, they underestimate highly intelligent students, and this might have negative effects on their socio-emotional development. So, is school a good place for highly intelligent students? There are different ways to organize school, and we also discussed special classes for the gifted. So we had a closer look at their role and if they could correct for these issues. But first of all, so what's the focus of schooling? And is talent development really a task of school? It seems that the focus currently is more on achieving predetermined learning goals rather than expanding students' knowledge according to their individual potential, that is, talent development. There are these two effects discussed in the literature, compensatory effects of schooling and the Matthew effect. And in the intelligence literature in educational psychology, when it is connected to gifted students, sometimes there's this argumentation, there's a Matthew effect, those with higher prior knowledge and higher intelligence, they profit more from instruction if it meets their learning needs. But actually, the literature shows the opposite. So there are a lot of studies, not a lot, but there are some studies, pretty good studies actually, showing that there is more of a compensatory effect. So education somehow seems to act as an equalizer, raising the knowledge of lower students with less knowledge, and all students learn. Most of the students learn in school, so there are gains, but these gains are smaller for higher intelligence students. So we had a look at this in gifted as compared to regular classes. Can we find these compensatory effects also in classes that are especially designed for gifted students? And these are classes where teachers knew about the intelligence of the students because they were assessed by testing, by probatory lessons. They had to write letters of application. So teachers had a lot of information about these students. And these are students in special gifted classes in schools of the German Gymnasium, highest track. These are schools in Bavaria and Baden-Württemberg that offer special gifted classes starting in grade 5, and they run to 10th grade, and in high school they are grouped together again. So this is kind of a school within a school program. And overall we had 922 students, 600 of them in regular and 300 in gifted classes. Here you can see how they differ. So usually students in gifted classes are younger. They go to school earlier or they skip a class in elementary school. They also have a higher need for cognition. That is a very consistent finding in our research, that high intelligence goes along with high need for cognition, but not the other way around. So high need for cognition can go along with every intelligence level. Therefore, there is a very small correlation. But if you group persons by intelligence and need for cognition, you find a consistent latent class or cluster group where high intelligence goes along with high need for cognition. And most of them were from very educated families in college degrees or PhDs. We assessed students' knowledge gains over the first 3 years in these special classes in 3 domains: mathematics, German, and English. English was a new subject, so it started as a new language in fifth grade. So students had very few prior knowledge. And you see that the knowledge gains in English were the largest, which can be explained by this fact. And here are the knowledge gains in math and in German. And in gray, these are the gifted classes, and in black are the regular classes. And it pretty much looks like parallel learning. No Matthew effect. So not a steeper increase in these gifted classes who had higher prior knowledge and higher intelligence. So we had a closer look at this, if this really applies to this data by using by growth curve models. So we used the first knowledge test in grade 5 to estimate the intercept as the amount of prior knowledge that a student had at the beginning of secondary school. And then we estimated the slope, that is the growth trajectory from these achievement tests. Again, they were scaled on an IoT scale, so this really is a strong difference score. And we used intelligence as a further predictor for the slope. And here are the findings for the regular classes. We have a pretty good correlation between the prior knowledge and the intelligence, which is not surprising in mathematics, German, and English, but we always have compensatory effects. So higher prior knowledge levels go along with smaller gains. The gain in itself is positive, so there is an increase, but this increase is relatively smaller the higher your prior knowledge. And beyond that, intelligence was a positive predictor for the slope in regular classes. In gifted classes, findings were pretty much the same. So also in these classes, especially designed for students of very high prior knowledge and ability, we had compensatory effect for German and English, not so for mathematics, and we had a positive impact on the slope by intelligence. And mathematics somehow was an exception, and we had a look at this. And in mathematics, in these gifted classes, motivational variables were decisive for gains. Not prior knowledge, not intelligence, but really interest in mathematics and need for cognition. So this is really complicated. It seems that gifted classes are not the one-size-fits-all solution. They seem to be beneficial, at least for these results in mathematics, but not so in German or English. Instead, we find compensatory effects in these classes. So higher knowledge went along with smaller gains. And we also matched students in gifted classes and regular classes and compared their knowledge gain over class type. And in mathematics, in fact, students gained more knowledge than in regular classes, but not so in English or German. So no beneficial effect of ability grouping for verbal subjects. This is really, I don't know, this is really difficult to explain because we also assess teacher behavior by diaries. They did acceleration, compacting, enrichment, individual learning. So, yeah. Okay, so to make to integrate all of these, so what is needed for successful talent development? Together with colleagues from the States, from France, England, and Graz, Roland is here. He's one of those. Roland Grabner. We developed this framework. It's just a very general framework to explain talent development in domains. And I know it's a lot. It's warm in here, and but I try to really to explain this in an interesting way. So we had 3 columns. The first one is developmental levels. We all know there are no levels. It's an oversimplification, but we wanted to separate between an acquisition phase and a performance phase. And the acquisition phase is characterized by aptitude and competence. And the achievement phase performance phase is characterized by expertise and eventually higher levels of performance, transformational performance. And this characterizes one way of talent development. It's not normative, but we wanted to use this framework to explain a trajectory that really also reaches these high levels. And this column here is probably the most interesting because we tried to identify processes that might be specific for highly intelligent learners. Because usually we can take findings from general instructional psychology or educational psychology of predictors of learning and just apply them to the gifted too. They work well too. But are there things that work differently? Are there things that are really specific for this group and that need to be taken into account to explain their trajectories? So we think that ability differentiation is one of these processes that's very, very interesting because we find a lot of evidence that with higher ability, I don't know if ability differentiation can be translated to profiles, that's another discussion, but specific abilities become very important. And we know that specific abilities have different predictive validity for different domains. So the profile that is predictive of talent development might look different in STEM fields, from verbal fields, and also from the study of mathematically precocious use. We already knew that these profiles are predictive. Then if things work well, you use this profile to select a domain that has a good match with your profile, and then by acquisition of knowledge and by deliberate practice, by training, by opportunity, you might eventually reach mastery, identify with the domain. I think it's very important that you really identify with what you're doing at this level, to have a lot of energy to do this and to find your niche and your style. And here you see level-dependent predictors and indicators. So what's central to this framework is that the predictive validity of psychological factors varies with level. So we would not use general ability, IQ, as a predictor for transformational achievement. This won't work because a lot of things are going on in between. And so we try to describe this process, and these arrows here are hypotheses for predictive validities. So at the beginning, ability, openness, need for cognition, motivation are very interesting variabilities to explain self-teaching, ease and speed of learning, energy, activity level. But as soon as you start to learn, if you go to school, you're confronted with domains. Privileged children might self-select a domain, but as you enter a domain, there's knowledge, there's skills to be learned. So you need to learn, and then intelligence is not enough anymore. You need to have the right self-concept. You need to be able to deal with drawbacks, frustrations. You need conscientiousness, deliberate practice, and also you have to have the right profile of interest and values to really get engaged and then gain competencies. And in the level of expertise, we think that self-regulatory abilities, metacognition, and also social skills gain in importance because you usually work in teams. You have to convince others of your ideas. And transformational achievement, usually if you have a new idea, you're not welcome in the field. And the first thing that happens is rejection. And you have to stand this phase of rejection. So this requires strength, persistence, and charisma. Okay, we tried to translate these variables into material that can support parents and teachers in identifying predictors of successful learning and of potential in these early phases. And we did this in different domains. And I show you some examples for math and STEM fields. So we know that diagnostic competencies of teachers really need to be supported, and we felt that we could make a difference here. So we developed materials like this. So these are sheets of papers, 50, the numbers 1 to 50 in a decimal system. And then we developed whole lesson plans for teachers. It's a 3-hour lesson that is related to these sheets. And students get those cardboards with a little window left out, and they are instructed to try out things. So what do you discover within this decimal system? Do you detect any rules? And this is just one example to show, to give teachers some occasion to observe their students' numerical thinking in a different way. The same with creativity. Here are some examples. Also, we developed interviews for prior capacities that explain math potential, like focusing on numerosity relations or patterns. This is interview material, questionnaire material. And this is freely available. It's now it's in German, but we translate it into English. There's a website to it, and it can be used in the first 4 years of schooling to support teachers to identify math science potential in students. And it has been developed within a 5-year project together with 40 elementary schools. So it has been tested in practice already. Okay, so to finish, I think we really need both. We need differential psychology, we need education and the instructional perspective to support talent development, because it really hinges on psychological factors, but also on opportunities. And educators are not trained to do this. And I think it's in our responsibility of this community to really change this. Because in the educational community, my impression is that intelligence is an ambivalent construct and it won't be changed from their sense. So I think it's really important that intelligence researchers translate their knowledge into material that can be used by educators. Yeah. Okay, so thank you very much.
Thank you so much. I think it was worth giving you the extra 15 minutes because you were willing to postpone your talk.
Yeah.
So therefore we really got a lot of information. We still have time for 2 questions or so. Yes, please.
Do you think, how close, if you sort of imagined teaching as going from completely not useful to sort of theoretical maximum use to people, I wonder how close we are to what the most that a teacher could possibly do. How much scope is there to improve schools, I wonder?
Yeah, I think schools are absolutely needed and central. They are.
It wasn't not so much that they're needed,
Yeah,
and obviously they're doing a great job. You were showing.
Yeah, because actually, when we cooperate with elementary school teachers, we change their focus. Many of them, when they start to cooperate with us, have in mind that they first need to identify highly intelligent students and then support them. But it's a different way around. I showed you the heterogeneity in trajectories in children. So we have a different approach. We first offer different materials, we stimulate and train teachers in observing reaction of the students and then start from there on. So it's a formative assessment. And we don't use IQ tests until an age of 8, 9, 10, not earlier. So, yeah, and without teachers, students that have no access to education at home, they would be lost. So school is just, yeah, I mean, yeah.
Yes, please. Sophie.
Great talk, thank you very much. I'm particularly interested in the parents who overestimate or underestimate their children's intelligence. Why do you think that is, and by what variable might it vary? Is it to protect your children from disappointment? So you say, you are actually not that clever, don't expect to go out into the world and have it easy? Or is it the observation at home, raising them, that you have to teach them a lot of stuff as a parent that changes the impression?
I think parent estimates are very prone to bias because they lack a comparison group. Usually you don't have access to a large group of same old children of the same age to really get an impression of variability. So you somehow, you need to rely on your own conceptions. And what I really found striking is when you, as soon as you get grades in school and you control for their impact, there is no relation between parents' estimates and children's IQ anymore. So parents rely a lot on the feedback they get from schools. And this is really something that can have a lot of good and also bad consequences for children because it's not objective.
Yeah, thank you. There are also sometimes results that at least 50% of parents think that their child is gifted. So we also have this overestimation sometimes, but yeah, it seems to be biased. Thank you so much again.